Hey guys, welcome to Industrial Automation It Doesn't Have To. I'm Brandon Ellis, your host, and this is Beth Elliott.
Hello.
So why are we doing this little precursor? Well, we had some technical difficulty with our video, the video portion. And all that means basically is if you're watching the video, we want to invite you to keep watching the video, but you're not going to see us speaking other than right now. So take a good look. This is what we look like. But there is going to be some video for the illustrations and pictorial examples. So please don't be confused, but stick with us. So today we're talking about an issue of global proportions, and that's the global supply chain crisis. Everybody's heard of this crisis, but we're talking specifically today about the semiconductor shortage and why that's a big deal. It affects every aspect of pretty much everything that we use that has a chip inside. However, there are some folks that have figured a way around, and for manufacturing, that we can learn from those lessons. And so that's what we're going to be talking about today. So join us. Hello, everybody, and welcome to Industrial Automation It Doesn't Have To. In case you're new to our program, I'm Brandon Ellis, and I'm your host and also the owner of elliTek. Before we start today's episode, I just want to ask that you consider hitting the follow button and the subscribe button, depending upon the platform you're listening upon. Also, if you're listening on Apple Podcasts and you enjoy what you hear, please go to the show page and scroll to the bottom. Leave us a 5-star rating and review. Now that we've got the marketing out of the way, I want to say thanks for tuning in. So let's get started with today's episode. Good morning, good afternoon, good evening. This is Brandon Ellis, your host of Industrial Automation Doesn't Have To, and I'm here as always with my co-host, Beth Elliott. Hey, Beth, good morning.
Good morning. How are you, Brandon?
Good afternoon.
It is almost afternoon.
Yeah. Good evening. So whenever you're seeing this, but yes.
Hey, everybody.
Oh, hey, on to the video. You got video this time around and last time as well. So that went well. We're getting a little bit better.
Better each time.
Each time. So
takes a little practice, but
that's
we're getting there.
Well, a lot of things have been going on.
Yeah. So did you want to talk about all the buzz going around the robotic welding?
Oh, around our shop?
Yeah.
Yeah, our last podcast, no, 2 podcasts ago. No, last podcast.
It was the last one.
Was talking about the robotic welding. And we actually have done some even more stuff. We had a couple of customers come down. And it was really interesting because they were here approximately an hour visiting our shop. And we have our Hanwha demo set up with one of our welders. And now it helped that one of them, they both are welders. So I didn't have to try to teach them my skill set.
That's a good thing.
Which is a good thing. They figured out real quickly that they were above me in that. But the interesting thing was we took about 20 minutes to show them we were using the Hanwha robot, and it took about 20 minutes of showing them. We answered some questions they were asking. They were good quality questions about, the maintenance, the upkeep, those kind of things. But then we pulled out the pendant, the control pendant, and began showing them how the storyboard programming works and that kind of stuff. And then there's also built-in features already that Hanwha provides for welding. And so the weaving, and the shapes of the weaves and how you can control the amplitudes and all that kind of stuff. And they were talking about that, but in the course of about 20-25 minutes, we went from us having, and I was watching, Sean Linus, one of our sales engineers, was doing this presentation, but he had the pendant in his hand, and through the course of about 20 minutes, had the pendant in their hand, and then in about 30 minutes from the time they first arrived, we were standing back while they were welding parts.
Oh, that's fantastic.
And they were talking about all the things that they can do and how they could apply it. And the takeaway for me was, as far as a success, and shows, our mission statement, we empower our clients, but we judge our products based upon how it affects them positively, and not just how, the quality of general quality and that kind of stuff that most people claim for their products. And so, the fact that within 35 minutes, they were not concerned about how to program the thing.
That's amazing.
They were talking about how to apply it and all the ways they can apply it. And we had test parts there. And so they're like, well, let's try this and let's try that. And they were setting it up. And they did all kinds of different types of welds. We just had a ball.
They weren't worried about programming it.
Right. and that to me fits with our mission statement. And that's largely why I'm so proud that we are, one of the U.S. representatives, the only U.S. representative at this point, but we're bringing this product to the U.S. Because it just speaks volumes about the product itself.
Yeah, it's pretty cool.
Yeah, and welding's always cool. I mean,
yeah, it is.
you get to make fire and sparks and that kind of stuff.
I don't think this episode's going to be as fire-filled.
No, this episode's. But it's hopefully not doom and gloom.
No.
But why don't you go ahead and hit us with the title?
Okay, so today's title is Industrial Automation. It doesn't have to be in short supply.
That's right. So we have this global supply chain crisis that's going on, and this has been, if you don't know about this, you're living under a rock.
So why is there a Chipageddon?
Chipageddon, yeah. So the supply chain crisis, we've heard about it in a lot of different ways. So right now we're coming up on the holidays, Thanksgiving here in the U.S. So for those of you in Melbourne, we eat a lot of turkey and ham. But they're saying we're going to have a turkey shortage. We're going to have all this
stuff. If you want a fresh turkey.
Yeah, and so we've talked about labor shortages, and there's all kinds of reasons for that kind of stuff. But then all of that has played into this global supply chain crisis. But one of the things that is not labor, I don't believe, is labor intensive, or at least it's a smaller portion, attributed to labor shortage, is the global semiconductor shortage. And so I'll give a shout out to my mom because I was talking to her about this because it has affected us. It's affected everybody.
Yeah.
Because basically anything that gets a chip.
It could be your refrigerator. Yep.
I'm holding up an iPhone. It has chips in it. Mm-hmm. And so anything that gets a chip, so why? Why is it all of a sudden, because before COVID, you didn't have trouble finding an iPhone, you didn't have trouble buying a car, you didn't have trouble doing those things, so what caused it? And so that's really what my mom was asking me. So what's the big deal about chips, Brandon? You're an electrical engineer, you're supposed to know about stuff like semiconductors.
That's all right.
And so it kind of kicked us into a conversation about that. And so the first thing was the why of why the demand all of a sudden. Mm-hmm. Well, that definitely stems from the beginning of the pandemic. So, and I feel like I don't want to be myopic.
That's right.
And be just
short-sighted.
But my experience is primarily the U.S. I'm not sure what the if it was similar in Europe and Asia and down in Australia and Africa and those areas. I don't know. But in the U.S., the first thing that happened was we shut everything down. Mandated shutdowns. Now, I know in Italy they did the same kind of thing, that kind of stuff. So everybody shut down, go home, don't come out of your house, those kind of things. But more importantly, school.
Yeah.
All the students had to go home. Suddenly and then all the employees went home, and it's a virtual learning extravaganza. And so guess what? Every webcam, every computer, every microphone, every tablet, all those things, guess what's in them?
Those chips.
Mm-hmm. And so then also, coincidentally, for those employees that were working, air quotes, working from home.
There's people that work from home.
They work from home.
I tell you what, I was very productive when I was working from home.
I know you were. But there was also a spike in the video game industry.
Oh, yeah.
And so everybody went out and started buying the new Xboxes and all this kind of stuff. And so guess what's in those? Chips. And so the last thing was people were going out and buying smart TVs because you couldn't go to the movies anymore.
Yeah.
So
You have to bring everything, all your entertainment that you would go
Came
out.
in the house.
You had to bring it home to you.
That's right. And so if you didn't have a smart TV, you couldn't watch Netflix and Hulu and all that kind of stuff.
Unless you had one of those casters.
If you had one of those, but guess what's in there?
Chip.
That's right. And so there was a push for all these chips suddenly, not to mention folks didn't stop spending.
Yeah.
And so there was if you're not at work and it's nice outside, you want to go out in a boat, go buy a boat, Well, guess what? There's chips in boats.
Yeah.
Go out and buy a new car. Go out and buy this kind of stuff. Get the truck you wanted. All this kind of thing. And so it was just a very even, but intensified demand for things that have microchips in them.
So why can't these chips be turned around so quick?
Why can't we just make more?
Yeah, right?
That's exactly what my mom asked me. Okay, that sounds fine. I guess I'll buy that, but why can't we just make more? Well, the reason is you grow a chip, a semiconductor.
How do you grow something that's manufactured?
Well, first, we grow it. So wood, boards that you buy at the hardware store or the lumber store.
I can understand that's a tree, so
that
it's
comes from
growing.
a tree.
Yeah.
So the raw material is the tree, and you make boards from it. So that's manufacturing lumber. It's kind of similar with growing a crystal. Trees grow, and you can't say grow faster. Tree. Hello, tree. I need you to grow faster. If there's a lumber shortage, you're kind of stuck until you can find more lumber that's already grown. Because if you're waiting on it to grow, you're going to be waiting for a while. Mm-hmm. And so crystals, silicone wafers, that's where a chip begins. It's a silicon crystal, and so crystals grow just like snowflakes. You've seen snowflakes with all the little designs, and if you haven't seen that, surely when you were a kid, you took a piece of paper and folded it up and cut little squares and stuff out of it, and then you pull it out, and it's a pretty snowflake-looking pattern. That's a crystalline type structure, and so that happens in nature. It's physics, and when you get down to the physical level, it's going to happen at whatever speed the good Lord said it was going to happen.
Yeah.
And so that's what's happening when we're growing these crystals, which ultimately, once we have that raw crystal structure, we then can fabricate that into, just like making boards out of lumber. They do a sawing process. It's a long process to create a wafer, and then from that wafer they treat it a couple of different ways. Now, I mean, I kind of have seen this done. I'm not an expert by any stretch, but ultimately that wafer is what the chips are actually built upon that wafer, and so it gets cut down even smaller and smaller and smaller. If you want to know what a chip looks like, pop the lid off something. Yeah, and look at that board and all those little squares and rectangles and that kind of stuff. Those are surface mount chips, and that's what we're waiting on. That's, they come in different sizes and shapes, and they do different things. I mean, some are capacitors, resistors, and some are actually microprocessors, CPUs. And so some do Bluetooth, some do cellular, what is it, not 3G, 5G now. And that's honestly the Bluetooth and the GPS and the 5G connectivity and stuff that we've come to love and depend upon.
Yeah.
That's the reason you can't find an automobile right now.
Because it's all incorporated into the vehicle.
So in talking about this, we've actually got some videos.
Yeah,
so for those of you
out.
who are doing this, so silicone basically starts as sand. And so
like sands through the hourglass.
That's right. And so if we we've got a little video here that we borrowed from the good folks at Intel, but kind of shows real quickly, kind of an
Just
animated.
Little sand there.
The sand, we take the sand and we heat it way up, and it becomes molten. And so that then is inside of a crucible or some type of a furnace, and then we draw that out.
What is that thing there?
That's the ingot. That's the raw material.
Okay.
And then we saw that into individual wafers.
Oh, look at that.
Yeah, so this is a good little simulation of that.
Yeah, I was trying to pause it so we could see it. Okay, there we go.
Yeah.
Okay, I paused
So
it.
you
right
end up
so
with a
can see the
round wafer, and
Yeah.
then that wafer's got to be, I mean, it's got saw marks that have to be taken care of. It's got to be polished, all this kind of stuff. And then ultimately they coat it a couple of different ways. They do this really cool stuff. That's where you see the folks wearing all the clean room suits and the outfits. And
Yeah.
this is top clean room environment. So clean room meaning no dust, no debris, no foreign material whatsoever, no fingerprints, everything. Everything's the way it needs to be, probably even humidity controlled for static and that kind of stuff. And so that's a good example or illustration of how that's made.
Okay.
You got a different video as well, don't you?
Yeah, I do. Let me get that one. Un momento, por favor.
Yeah, go ahead.
Okay.
So,
I'm still getting
but
there.
growing the ingot is really cool, but that's something that takes a long time. So in that little illustration,
I'm just going to pull this one over.
Sure, go ahead.
Because I don't think you could see the whole thing.
go ahead.
Okay. But see, there's the crystals, right?
Yeah, so the crystal's there in the middle. Go ahead and start it there. Yeah, so they're just moving those around. They're heating those up. Those are going to be that's like the sand in the illustration that we did.
Okay.
And so yeah, keep going.
Okay.
And so that's going to become molten, and then we're going to apply a little tip in the end of it. And it's according to what you're making. It's according to the size, the shape, the geometry, the complexity. But it's going to be pulling that out. Now, this is time-lapsed, I believe, because it's coming out pretty quickly. But
you told me it's like making a candle, right?
Yeah, if you've ever been to Pioneer Days or Heritage Days, the way you used to make candles.
Did you make it in elementary school? I made candles in elementary school.
You did?
Yeah.
I tried to make a candle once, and it didn't come out really well. But I didn't have a lot of patience either. So, yeah, go back to that.
Okay.
Yeah.
Do I need to rewind
Yeah,
it?
back it up to where
Okay.
it was drawing it out. So there you can kind of see the ingot coming down. So that's what the ingot looks like once it's cooled down. It's kind of a black material. But what they do is they draw it out, and so it's according to how they're doing it. They may spin it some, but they're drawing it out ever so slowly, kind of like dropping that wick into the hot wax and then pulling it out.
Okay.
So you can see it kind of pulling out there. You can see it spinning. Sometimes they spin those, and again, that's according to the type of manufacturing you're making, whatever you're making. And so that's the whole machine that's drawing it out. And then once it gets done, then you can see they're lowering this back down. That's what the ingot looks like.
Okay. And
now,
I think we've got pictures of those, right?
Sure, yeah. Bring those over. And so that's why it takes so doggone long, is because you've got to make that raw material ingot.
Yeah, I will get that over there.
Yeah.
Yeah, my side-by-side picture isn't working out. That's why I went
We're
to
out
the
of
full
the shot.
screen. Oh, and now it's work. Doggone it! I still have some work to do on this.
That's all right. Okay, so enough about that. I mean, you can kind of see how it's done. So for those of you who don't have the video, we're inserting a I don't know what they call it, some type of they call it a probe or something, but that goes into this molten material, and it begins to slowly draw this out. And this process could take anywhere from 1 week to a month.
Oh wow!
To build that ingot.
It's looping again. I'm sorry, Brandon.
You're
sorry, everybody. I'm gonna turn that off.
Okay. All right. So, are we going to talk about that stuff yet? Or you're just having fun?
I'm just clicking away over here.
Beth's got the mouse in her hand.
Watch out.
I have the the sound effects here, so I can do all my sound effects. But Beth is producing the video, so have at it, man.
Yeah.
That keeps it changing. But it can take 1 week to 1 month, and it really comes down to the quality of what the quality aspects, the size, and just the general complexity of what that ingot needs to look like. And then they've got to do the sawing and the polishing and all that kind of stuff. And now they've created the base, the wafer, and then you got to print the circuits on there according to what they're going to be. Are they going to be resistors, capacitors, microprocessors, what? And then that gets sawed up into little places and little pieces, and then it gets placed. It's ready to be placed on the board. And so that whole process can take up to 3 months.
That's incredible. No wonder it takes a while. There's also cost involved, isn't there?
There's nothing cheap.
No.
But yeah, it's a very costly process. It's why. So why doesn't my mom said, "Well, Brandon, you're smart. Why don't you just do that?"
Yeah.
I don't have the money. First of all, we don't. We would. I wouldn't. I probably don't have. I don't have the skill set, but I can do the motion.
Yeah, I've read. It's not rocket science. It's much more difficult. That's what industry insiders say.
Well, I mean, because you think about it, you're looking at physics, you're looking at chemistry. All these things come together because the chemistry says, and the material science says, this is how we'll grow the crystal. The physics says, I need to do it in a controlled way to build the ingot. If you go too fast, you break it off, so it breaks prematurely, or you may have fractures, you may have all this kind of stuff, and suddenly portions of or all of that ingot that's taken 3 months or a month to grow is not useful. It's like a piece of lumber that once you cut it into a board, it's got a crack. It's got a crack down the middle.
Yeah.
And so now you really don't want to use it, so you have to cull it. Well, if it took 3 months to get to that board, it's an expensive board.
Yeah, you gotta have some quality in place.
That's right.
For that.
And so it's not for the faint of heart.
Mm-hmm.
Most of our chips come from Taiwan.
Yes, I was reading that there. I think there's 3 major companies that provide chips.
Yeah, yeah.
So it's the. Oh, it's not on this piece of paper.
No, you're not.
Nope.
Well, Taiwan is the leader. Is
Yeah.
the market leader, and Intel read recently is looking into. I don't know where they're going to put it. If it's going to be
Arizona.
It's going to be in the U.S.
2 plants. They announced plans to spend $20 billion to make 2 plants in Arizona.
So that'll help.
Yeah, it will, but it's going to take a little bit. Now, I was also reading where even if you invest all this money in 5 years, that it's going to be obsolete. That technology is going to be obsolete. So it's really it's hard to justify spending that much money, and then it's going to be you've got to keep on changing it every 5 years at least. But I don't know. So I also read where they have to run 24/7. The chip plants do.
You can't turn it off once it's molten. You can't say, okay, just turn the heat off.
Yeah.
And you need to be watching it, just because honestly, you don't want to lose any time. So if there's something that does happen, if something that does happen to the ingot during that growth or during the sawing or something, because the sawing is not it's not like that illustration.
Video that
Yeah. It's a slow process, and if anything happens during that, you want someone there to go ahead and arrest it, restart it, do something, or maybe even try to save what's there and keep it from doing further damage. I don't know. I don't know. I assume.
Okay.
They're pretty smart people to be able to do it to begin with. So, but what you don't want is you don't want waste. You don't want to do all that work and then have to throw it out.
Oh gosh, no.
And so it's hard to do that in a lights off factory.
So I think how long do you think the chip shortage is going to last? What have you read? I've read 2022 and 2023.
Well,
it just depends who you're.
Well, okay, so again, let me just say I am not an expert on any of this stuff that I'm about to say, but what I've read is apparently there's different types of chips as far as thickness, and so the automotive industry has chosen as a standard one thickness of chip or something, and then also I should call some friends of mine who do the surface mount technology and stuff like that. They can probably know this, and then there's different thicknesses or types of chip.
Yeah, they layer. Oops, I'm sorry. They layer the stuff on it.
Well, the board is layered.
Okay.
On a silicone board, and that's what the chips are going on.
Okay.
So that's where you have your traces and stuff like that. But when you're making the chips, how you saw them, when you're sawing them, that wafer thickness is what I think they're talking about.
Oh, okay.
And so apparently automotive uses a different thickness than your iPhones and your PCs and stuff like that, general consumer electronics. And so my understanding then is and I don't know that one's better than the other, maybe, I don't know. But because of that, you have more people, there's more production of commercial grade chips with that thickness, whatever that thickness is, versus what the automotive folks are using. And maybe it has to do with the fact that you're sticking a chip in a car, man. That's a lot different than your iPhone.
Yeah, it's got to operate a lot more things.
Yeah, it's got to sit outside in the cold. It's got to be in the desert heat. It's got to be in water and rain and all this kind of stuff. So there's all these environmental things. And granted, those things are put in place, different places. But your humidity levels change a lot more in your vehicle than they do inside, say, your home.
Yeah.
And we all know what happens if you change the humidity level of this too much. You end up with a new one. So if you drop this in the water, if this goes in the mud puddle or crashes through the stream, it's probably not going to work anymore.
Well, except for some new ones.
Maybe some new ones, yeah. But you understand what I'm saying.
Yeah.
It's apparently a different grade of chip, and so therefore, it's been said, what I've read, is that the automotive shortage is going to last longer because of that than perhaps what we would see with commercial type devices.
Okay. So is there a fix for manufacturers? Have you seen anybody that's done anything different that's
so let's talk about the worst one, and that's automotive, and you can pull your graphic over now.
Finally. No, I play.
Explain this graphic to me.
Oh, this is the U.S. auto sales, and it's quarter 3 of 2021 versus quarter 3 of 2019.
So we just came out of Q3 2021.
Yeah.
So this is now. And who's at the top of the list?
It's Tesla.
Okay. So where's everybody else? Do you see? I read about Ford. Ford's down.
I'd have to really get that.
You can't tell which one's which.
No,
Tesla is absolutely, it's really small on her screen. Tesla is absolutely at the top. So why, you see that, why are they so much more? I was reading Ford is down year over year, 27%, I think.
Well, the U.S. auto sales as a whole, all those are down 22%.
Yeah, 22.
So they're probably within that range.
But the only reason they're not higher is because look at that Tesla one. Tesla is up about 25% year over year.
Yeah.
And why? So why is that? So what can we learn from Elon, Mr. Musk? What we can learn is that he has done some things that maybe the bigger ones weren't comfortable doing.
Okay.
Or they didn't happen to own a SpaceX with...
That's true. Rocket scientists.
kind of a mind trust there. I don't know if that's how he did it, but what Elon did was Elon decided because everybody has orders. Yeah. There's no shortage of orders.
No, because even the car commercials are saying, instead of come and buy your car, order your car.
Order your car. Do pre-orders. Because they're assuming this is going to go away. And it will go away.
Yeah.
The question is when. And so, but Elon didn't want to wait. And so there were a few car companies that went out there as soon as they saw it coming, they went out and did bulk purchases and tried to grab all the chips they needed and all this kind of thing. And now they're actually starting to run out. But Elon said, okay, guys, he pulls in all of his brain trust and says, find out what chips are available. Because, okay, so what? There's a mom question. Well, Brandon, why can't you just use another chip?
Yeah.
There's Lay's and there's Doritos. She didn't say that. No, why can't you just use another chip? And the problem is each manufacturer, chip manufacturer, especially if you're talking about embedded type controls and CPUs and processors and things of that nature, more than just capacitors, resistors. If you're trying to run your software, we call that firmware, trying to run your firmware on that, each one may or may not support your firmware, and so you would have to do what's called a rewrite on the firmware, which is a very costly and involved process. It'd be like Bill Gates with the Windows operating system having to rewrite Windows to run on a different, not run on Intel, but to run on something else. So they would have to rewrite all their systems to do that, and that's quite an undertaking.
Yeah.
Well, that's what Elon did. That's what Tesla did. They took that undertaking on, and they went out and bought chips that were various types of chips and rewrote their firmware to make sure it would operate on any of these chips that were available and begin to bring those into the cars. And so they were able to
bring all that in-house
and meet the demand. And so, and they actually, I'm sure, picked up some new customers.
Oh, yeah. So I was going to show you, this is the graphic of their sales. So
Yeah.
wouldn't that be nice?
Yeah. So, you know, everybody else, what you see here is I hope you see is if you're in manufacturing, it doesn't matter what you're manufacturing, there's hope, right? Mm-hmm. And so.
Yeah.
Because if they can do it,
I've done something here.
You can do it. And so that's what you that's what you need to keep in mind. So let's talk about that. Let's talk about how we can use who's using what Elon did to make this happen. That's what's going on. So if you're in manufacturing and you're looking for this if you're a machine builder, and that's who we relate to, is machine builders, systems integrators, and helping them to succeed.
Yeah.
How can they go about doing this? And so there are.
I was going to ask you first.
Okay.
What manufacturers are waiting on?
You mean the end users?
Yeah,
okay.
yeah.
Well, that's what I think end users are waiting on, just like machine builders and systems integrators and elliTek. I mean, we are waiting on. We have a whole list of orders that we're waiting on one or two components that are in short supply because of semiconductor shortage. Mm-hmm. And so it's affecting everyone.
Yeah.
So what you got to do is you got to figure out
other
options.
Uh-huh.
And so whether you're whether you're waiting on robots, servo motors, there actually is even we're talking about semiconductors today, but there's a steel and aluminum shortage.
Yeah.
And so that's what people are waiting on. That's what's keeping them from taking the next steps, completing the projects they're working on, that kind of thing.
So how can they overcome that? How can they get past that? What are their alternatives?
You can, I would say, look at Elon. Learn from Elon. And that's what we have done. And so we have gone through, worked with our specific partners to actually figure out where they're, what steps are they taking? For example, I just mentioned aluminum. Uh-huh. So we do aluminum extrusion. So it's a T-slot framing that we use and we sell. And so a lot of our machine building customers and systems integration customers and end users use it to build machine frames and guards and stuff like that. But aluminum is in short supply for those that did not manage it well. And so our partners have managed it well. And the way they did that was, the first thing they did was they said no bulk sales, no bulk orders. And so some of the other folks, I think, when someone got the indication that there was going to be a shortage, it's just like toilet paper all over again. Oh,
goodness, yeah.
They just went and bought it all, and it just played out all the billet. And just like ingots with the silicone, aluminum comes in what we call an ingot or a billet. And so that's what's melted down and extruded, pushed through the extrusion machines and made into this extruded aluminum. And for us, the bulk sales was eliminated, and so we were able to manage the billet. And so what do we do instead?
Yeah.
We do an engineered type kit. So everything has to be kitted, but that means, honestly, when you get it, it's going to be machined, cut to length, ready to go.
Wouldn't that take longer to get it?
Well, not compared to not having billet.
Yeah.
But we can, because we're managing it all, we can get aluminum kits to anyone in usually 1 to 2 weeks.
Oh, wow. Okay.
And it's huge.
My goodness, that is.
And everybody else, I'm hearing 10, 12 to 20 weeks.
Wow. 20 weeks.
Some have been that bad. And so being able to do that is really a testament to the partners and the folks that we work with. Mm-hmm. So that's aluminum. So let's talk about
what other metals?
Well, there's steel and steel. Okay, so steel. We represent Nidec Shimpo servo gearboxes and they do also just standard gearboxes as well. But we use them for our servo gearboxes. And they're managing their materials very well.
Okay.
And so we can get gearboxes in a week, 2 weeks, if it's a complex or an an abnormal gearbox or ratio, then it may take a little longer, but that would take longer anyway. So for a standard ratio, standard servo for standard servo products, we can probably get that done in 1 to 2 weeks, maybe less.
Wow, that's good.
Yeah. And of course, if it's through our systems group, we can ship that anywhere in the globe.
Okay.
But then we also usually put that with something else. So Hanwha robots, we don't stick gearboxes on those, but our robotics, Hanwha is keeping everything in check. They're doing a great job. So we can get robots in 3 to 4 weeks.
Yeah.
Now, normally we could get them shorter than that.
Yeah, but there are some places that the robots are.
I heard of one the other day. A customer was quoted 75 weeks.
Oh my word, that's a year and a half
on a
oh
robot.
My goodness gracious.
75 weeks.
Oh wow. And you can say 4.
What?
You can get a Hanwha within 4.
Well, now, granted, that robot would carry a lot more than having
the payload. Okay.
But actually, no, I'm sorry. It's not true. It was a collaborative robot.
Oh.
Just like the Hanwha. In fact, that's what I guess I told them. And as you bring that up, I was like, hey, we can take care of you right away. And so, but yeah, I mean, it's just it's a testament to how bad things are getting. And from a logistics standpoint, it doesn't have to be, but you need to choose your partners wisely.
Yeah.
So the ones that have kind of prepared for this, who have been, they've taken the steps to make sure that they can still meet demands, kind of taken, whether or not they took a note from Elon himself or not, that's what they've done, and that's what we've done. Our IOTA product. We have ample stock for the IOTAs. Now, I can't say that it's infinite.
Yeah, that's true.
But if you need an IOTA, one of our IOTA MES appliances, we can ship it, in less than a week. Mm-hmm. We're on normal deliveries on those things, and so, we've managed that well, and so I would encourage end users and manufacturers to take that into account.
To find other sources.
Yeah.
So speaking of other sources, in the semiconductor. What about motion control and servos?
Motion control and servos.
We're going to have a special guest on to tell us about that.
That's right. So let's get to that right now.
Yeah, so we've got Jon Fields with Yaskawa, and Jon is the Senior Motion Sales Engineer. Hey, Jon, how are you doing?
I'm doing great, Beth. How are you?
I'm doing fantastic.
Hey, Jon. Hey, so I appreciate you joining us today, Jon. So we work a lot with Jon. He's our rep for Yaskawa Motion here at elliTek. And so, Jon, what we're talking about today is the global supply shortage, specifically semiconductors, and more importantly, manufacturers such as Yaskawa that have taken steps to kind of overcome this shortage and are continuing to do so today. What kind of things, in your opinion, quickly, is Yaskawa doing, either traditionally or currently, that's helped overcome this stuff? Because I know you all got stuff on the shelf.
Sure. Historically, Yaskawa America has maintained a fairly significant volume of inventory in our Buffalo Grove, Illinois distribution center.
Yeah.
So we have kept roughly $65 to $70 million worth of inventory spread across motion control products and VFD products over the years in that facility. And over the past couple of years, we've worked closely with our demand planning group to increase that volume of inventory. So we're now closer to $85 million to $90 million worth of inventory. So that's really helped us weather some of the logistics issues that we've seen from some of our competitors and even some of our partners that have run into some of those problems. So keeping that inventory on the shelf, that's helped us really get into places that we may not have had an opportunity to go into in the past, because we do have product available.
Well, and I know that and specifically, Jon's over he is his main product line within Yaskawa is the servo, what we call motion control products, servo motors, drives, linear motors, the large linear motor product, and not so much the VFDs. Do you know? I know I'm asking you, putting you on the spot. What the status is with the VFDs? I'm not as aware of that.
There has been some further delays with the VFD product line. Again, I don't work as closely with that group. I know we've had to do a couple of things where we've had to add some surcharges for some products. When you get into some of the larger VFDs and actually some of the larger motors, some of the components are a little more difficult to come by, with metal shortages and semiconductor shortages and things of that nature. But from the motion control standpoint, we really haven't had to implement any drastic programs like that where we're adding surcharges or, having to extend product deliveries. So most of what we consider our stock items, our motion controllers, our Sigma 5 and Sigma 7 product line, most of those products are all what we consider stock items for us. So, like I said, we've traditionally kept a large volume of those products on the shelf. So, at any one point, you could, call up and say, I need a 1 kW servo motor, and we may have up to 100 of them available on the shelf. So,
well, we've seen
that's
that.
been key for us.
We've seen that. I mean, I know personally we've had customers of elliTek customers, and of course this podcast goes out to a lot of folks. But for the East Tennessee region, and of course through our systems group, we've talked about how we can go even outside of that when we start putting systems together. But we've had customers that were basically in a quandary with competitive brands of servos, and we've been able to go in with the Yaskawa and get them up and going because of that good management, I call it, of product on the side of Yaskawa. So, well, Jon, I appreciate you kind of giving us a little insight and adding some validity to what I was saying and what Beth and I were claiming. So it's good talking to you as always.
Absolutely. Good talking to you and Beth as well. And I appreciate the opportunity.
All right. We'll keep selling Yaskawa.
Right.
You all keep stocking it.
Will do. Thanks, you.
Jon.
Take care. And bye.
That's good to know, isn't it?
It is. Jon's full of great information.
Yeah.
He's a blast to have around.
Yeah, and Yaskawa is such a great product.
Yeah.
We've been using Yaskawa for a long time. And again, through our systems group, even if you're in Melbourne, Australia, we can take care of you. If you need MRO spare parts like that and you're in our region, we can take care of you on that. But definitely through our systems group, motors and drives together, coming through our Knoxville systems group, we can take care of a lot of things for you. And they're in supply. And so if you're waiting on something else, and this is not a sales deal, but this is just reality. If you've been waiting for a long time and you're hearing, these kind of things, you can be Elon. Be
proactive and look at other places. And there is another one of our partners.
That's right.
So it's LinMot.
LinMot linear motors, and another product that I just absolutely love because linear motors are cool. Now, Yaskawa makes linear motors. They make really large linear motors. Yeah. LinMot makes smaller linear motors, and so we use them to replace a lot of pneumatics and a lot of electrics where we need high speed, high thrust, high acceleration, and that kind of stuff. And so today, we're going to be also special guest.
Yes, Peter.
Yep, with LinMot.
Another guest we have with us today is Peter Zafiro, the general manager with LinMot USA. Hey, Peter, how are you doing today?
I'm doing well and enjoying life.
Awesome.
Good. Hey, Peter, this is Brandon. Thanks for joining us today. So Peter's on the road, always getting it done. Is that right, Peter?
Yeah, that's the major part of my job description, for sure.
Yes. And you do a great job. So LinMot Linear Motors, a partner of elliTek's, one that we've known for many years. And so, Peter, what we're talking about today is supply chain crisis, specifically with global semiconductor shortage, and steps that companies have made to kind of overcome these shortages. We talked about Elon Musk at Tesla and how Tesla, experienced a 25% year-over-year growth, whereas all their competitors were like 25% down year over year, and by doing some kind of things. I wanted to talk a little bit about LinMot. I know LinMot's not had the delivery issues that many of its competitors have had across the last few months. What steps has LinMot taken and will continue to take to overcome these issues, especially with semiconductors?
So we some steps are no different than what we normally do. We have always bought for large production runs. If you will, you can call us the anti-lean manufacturing company.
Anti-lean, right? Yeah.
Yeah, you bet. Yeah, because when you're lean, you buy as little components as possible. You have your supplier provide you components on a weekly, in some cases daily basis. So your work in progress is as low as possible, of course, and makes the bean counters happy.
Yeah.
However, in a time of crisis or supply chain disruptions that we've seen now for close to 6 months now, it's been pretty tough. Semiconductor chip shortages are real. It is happening. The difference with us is we purchase semiconductors for a year's worth of production, and we continue to do so even in today's elevated prices, because this is how we do it. We run our company on large batch production runs that are built to sub-assemblies, and then we do final assembly, and with drives and motors, we do our final QC and motor testing, drive testing, firmware burn-in, flashing the firmware. All of that is done then in small production runs, but the major, if you will, the major components are built off of inventory of a large volume of semiconductors that we have in-house or at our suppliers' installations.
So more of a buy ahead kind of model.
Well, we can't escape the disruptions that are happening right now. We are doing exactly the same that Tesla is doing as well. There are some semiconductor components where we anticipate seeing disruptions, and what we're doing is exactly what Tesla's doing. We're redesigning boards, redesigning PCBs. We are looking at using substitute microprocessors or semiconductor chips in some of our, like for instance, in the network capacity, there's a huge demand now for network chips. So we are second sourcing or triple sourcing some of those components. In some cases, that requires changes in firmware and a lot of testing. Puts a lot of pressure on our production engineering group, but it's the only way to stay ahead, if you will, to be able to produce low lead times.
Well, and make no mistake, Tesla's bunch, Elon's been working them hard to rewrite firmwares and do kind of the same thing. So yeah, it's a strain on engineering, but it's what you have to do. That's exactly right.
And I think the companies that were subscribing to this ultra lean production environment really have to think about in the future, how do we deal with disruptions in the logistical supply chain, which is now happening daily. There are daily calls coming in. Oh, this is not going to be delivered on time. Mm-hmm. And if you're depending this shipment to keep your assembly line running, what do you do? What happens when it doesn't get delivered a second day or a second week or a second month? Yeah. This is reality.
Yeah, and it's a new reality. Unfortunately, I hope that unfolds soon. Port shortages, labor shortages, there's steel shortages, there's semiconductor shortage, and there's even resin shortages that are affecting a lot of folks. But you're exactly right. So the fact that LinMot right now, I mean, as of today, here in the U.S. anyway, I feel like that the deliveries, the lead times on the shelf product is close to maybe an extra week or two, but nothing way unreasonable for getting product. Is that still the case?
You're correct. I mean, we're running in that 3 to 4 week lead time for off the shelf products that normally we would call off the shelf. Normally be 1 to 2 weeks. We're now running 3 to 4 weeks. The volume is higher. There's no question. We're having a record year. That's for a couple of reasons. People are using our product to substitute product they can't get.
Yeah.
And that is happening. We see that. There's also, you alluded to the resin shortage. We know there's going to be issues there down the road, and we're working hard at developing second source vendors, triple sourcing vendors. But this supply chain crunch isn't going to go away like tomorrow or next week,
right.
or maybe not even by the end of this year.
Well, many are saying, unfortunately, that it's going to go well into Q1, Q2. Some are saying even Q3 of 2022. So now that crosses a lot of industries and a lot of segments, right? So we have to be reasonable on that. But it's certainly great to hear that. And that's what I love about LinMot and about your leadership there, and just the company's leadership as on the whole is just the awareness and to be able to jump in and make those changes. It just speaks volumes about your all's dedication to the product and the quality of the product, but also just the success of the company in and of itself. So we appreciate that.
Well, thank you, and thank you for supporting us.
Well, what I heard you say. I'm sorry, I didn't mean to interrupt. What I heard you say was, if you need a small linear motor, you need to do two things. First of all, you need to check out, what's the website, LinMot.com?
LinMot.com is the website, and you can also get to the USA sales at LinMot.com email if you want to just email the your specific application or even just general data. We will have one of our technical sales engineers get back to you. Of course, if you're in the great state of Tennessee, I think they need to contact you, Brent.
That's right. Yeah. That's right. That's the number two thing is call elliTek and go to our website. We of course, Beth has a beautiful LinMot landing page. So definitely, if you're in our region, we are a partner with LinMot, and so we're here to help as well. With our systems group, if we're combining it with other things, certainly we can go outside of Tennessee. But it sounds like if you need linear motors, now's the time because there may be some other things affecting because you just don't know. And that's the problem with this supply chain crisis. You don't know if it's going to be due to steel shortages, resin shortages, labor shortages, semiconductor shortages, or shortage of something we haven't even thought of yet. They say there's going to be a turkey shortage come Thanksgiving. Have you heard that one?
I mean, I know the prices are going up at the grocery store, so nothing surprises me.
Well, I tell you, a ribeye steak. This is my world. A ribeye steak costs more than a restaurant if you buy it in the grocery store right now. So, yeah, things are getting all crazy.
Well, that's definitely. I mean, this is the real world we live in, right?
Yeah. Well, listen, Peter, I appreciate your time. Thanks for joining us. I know you're on the road and traveling, so thanks for taking a few minutes.
Thank you, Peter.
Thank you, Brendan. Thank you, Beth, and have a great day to everyone.
Thanks.
Take care.
So LinMot, that's an awesome product line for us.
Yes. And Peter's full of great information, too.
Yeah. And so they're just monitoring their stuff. They're just being good stewards of what we need. They're a little bit. They may be on some things a little bit longer than they were before, but just like everybody else. But man, they're not 10 weeks, 20 weeks, 60 weeks.
75?
Yeah, it's nothing like that. And a lot of people are. And hey, I'm not sitting here trying to put us on any pedestal. We've got some other things, some other parts that we've been waiting on since May. And so it's a real deal. Not everybody's doing this. So if you're facing this as a manufacturer, you're not alone.
Yeah. It's
through no fault of your own. This is a global crisis. But our goal is to give a little bit of light at the end of the tunnel to say here's the way you can see it through. And honestly, if you're not familiar with great product lines like Hanwha robots or LinMot or Yaskawa motion control, there's three right there that will absolutely that'll be your specification. If you go that route, that'll be your specification going forward. I guarantee it.
Yeah, because I know you wouldn't pick a product that you wouldn't stand behind anyway. So.
That's right.
Yeah.
Well, we try not to, but I've got a lot of history with those, and so especially with the Yaskawa and the LinMot, and I'll tell you, I think they're second to none. Yeah. And we know them well, and we've had a lot of successes with them.
Yeah.
So not all doom and gloom.
No, and it doesn't have to be in short supply.
In short supply, that's right. There's a way out. So thanks for joining us today.
That's right. Thank you,
Been
guys.
a good day. We've had all kinds of video stuff. If you watch this on
Yes,
video,
I'll get better.
Beth is doing her thing, and then we've learned a little bit about how
overlay
that, and then also how silicone ingots are manufactured.
Yes. Let's get a picture of those wafers again.
You want to see the wafers over top of it? Okay, all right. So there's a wafer, and then what you can do to possibly kick the can on down the road, so to speak, and not be feel the grasp of this crisis, especially if you're a machine builder, systems integrator, or if you're an end user that's got those capabilities in house. These are some examples of products that you could do, and these are just a few examples. Start asking the questions. Don't be afraid to look outside of your normal box of parts. It may change plant specification, but that's not a bad thing. Sometimes change is good.
If it can keep you going.
and the salesperson in me will tell you, especially when we're talking about servo motors and drives, if your spec is not Yaskawa, you should really think that one through.
Yeah.
Because the Yaskawa, of course, can hang right underneath a Rockwell system. It can hang right beneath an Omron system, any EtherCAT drive. So back off, any of that kind of stuff can drive, and you get the motors and drives that are top notch, and you don't have to worry about them, and they all come together, and they're not in short supply, and then you take it from there. And so, changing plant specifications is not a bad thing. Give us a call, and we can help you do that. So elliTek, 865-409-1555, and our website is www.ellitek.com. That's ELLITEK.com. Of course, you can find us on Facebook, Twitter, Instagram, LinkedIn, and our YouTube channel.
Yeah. Subscribe to our YouTube channel so you can get updates on this, as well as some fun videos that we put up as well.
And like. 5-star rating. Those things help us. They get us. They help Beth with what she does and works so hard to do to keep us in the top sections of all those podcast streaming apps and all the magic that she does. So, Beth, thank you very much for being a wonderful videographer.
Oh yes, we're getting better.
Producer today.
We'll get better.
So here we go. Yeah, congratulations.
Thank you for your time and the knowledge about the chips.
And
growing silicone.
It's just a weeny little bit of knowledge, but it impressed my mom. She felt good about paying for my education.
There you go.
So there was that. Yeah. All right, everybody, have a great time. We'll be back in another 2 weeks with another great topic.
Yeah, that's right. Thank you, guys.
See you, Beth.